some sinusoidal functions, specifically some cosine ones. I've got an example here today that came in from a student, and I want to go over this. Let's start by reviewing the anchor points for cosine of x in radians. I mean, a pretty generic looking Cartesian plane here, labeled in single units rather than by increments of pi, because that's what tends to pop up from time to time, or more often than not, on a Academy, is what I noticed. So we'll get used to dealing with this and remembering that increments of pi are somewhat easy to estimate as long as we get 2p. So on the screen here, you can see the black list for the anchor points of let's see. Like a remember this earlier, this is on the YouTube channel, is when we introduce ways of changing this, ways to change this. I mean, think about this, I love them. So say with like stretches horizontally, or horizontal shifts, which with the trig functions, the sinusoids, we call these shifts. Okay, so the value figure here, the length of the cycle of this sinusoid is phase. Okay, so here I'm going to keep, because that would be a shift sequence of the. Okay, and for D1's kind of the one I want to talk about. That line. We call it F5. But because we're dealing with this function oscillating above and below midline, think that value as the midline. So in this case, is added to the very end. So you could think of, so midline, which those points are oscillating around, is 0. Okay. Before I leave this page, just remember cosine. We can identify cosine from sine because they're both sinusoidal functions. By locating that anchor point being at the amplitude. Okay, so a positive cosine, like we have here, is going to start at its positive amplitude relative to midline, and then it's going to cycle through. So top of your amplitude, there's no but down through the midline, bottom out, point time we the beginning. You heard we're using units in terms of radians, but we have labeled in terms of radians. It's, or I shouldn't say that. We don't have it labeled in terms of increment pi. So pi on the scale. Now through the cycle, we're at pi radians, and 2 pi, which is really 6.28, is a little bit 6 there. So I'm eyeballing this, half of 3.14, 157-ish. So that those 4 dots out. All right, let's look at a specific example. This was about. Okay, so we could see, I would call this 4 transformations. Okay, and start with, yes, it's a cosine function. So that identify the pattern of anchor points. But look at it. So I'm going to take, if I do this on paper, I just take my lightly and a midline, maybe dotted line, something. But I'm gonna just wait there, please. Okay, so that'll be helpful. Now it's going to oscillate above and below that. Now let's look at out front. The amplitude is how far above and below that this function is going to. So I move base here. This be able to show both sides of the graph here. Colors I have in the last. Go blue. Amplitude 3. Everybody. So rather than 3 above the midline, cosine typically at least 1 above, but we've got amplitude. So cosine 3 above, oscillate down to 3 below, and so on and so forth. We do start, because of the negative, we're going to start 3 below. If you're shooting above the midline, you're going to oscillate down. If you start below the midline, you're going to oscillate up. It's always going around that midline. Okay? So I know that's where a point is. Figure out how the points lines up here. I need to go in green font and you to understand how period is. When we learned to it equals divide the b. That fraction in this case for b inside of for difference. So if I do the same thing times 6. So 2 pi over 1 times 1 over pi, multiplication by the reciprocal instead of division. You end up with pi is 12 units. That's on scale. We can go from 0 to 12, and I put my acid on here. I might be dealing, I think a lot of times the scale stops at 10. Okay, so I'm going to go in both directions. And see what the important thing though, if well, it's very easy to get the dots filled. So just real quick, back to the point parent function. The point for step 1 type period. Again, page. On this one, I could each just by 4, and I'm going to get pi half, and this pi for that one, pi all the way there. All right. So back period. Okay. So step 12 divide that with units to get my anchor point. So 1, 2, 3. Up through 1, 2, 3 puts me at 6, and I'll be top again far in the midline. So we get 3 up there, and it's lower back than now. And your graph might end, and that might be all you get on this side. So that pattern, this is going to mirror over the west. Here, good. No matter which direction you're looking here. sure enough have I got trouble. Yeah, if I still get up, I'll take more of this. Help. You have the beating effect help scale. I think really with third point. Mid of six, cosine typically starting above that vertical to below instead of, and by the distance of that amplitude from the midline. You can get points there. That's now. I hope that helped.